concrete example of what I mean by order here. Let's try out 4 cubed. 4 cubed is congruent to 1 mod 7. And that's because 7 divides. You guys may have seen this vertical bar notation. 7 divides 4 cubed minus 1. Okay, those are equivalent statements. Let me put that in parentheses. And notice, y'all, that 4 cubed minus 1 is equal to what? 64 minus 1, that's 63. Okay, so 3 is said to be the order. This value 3 right here is said to be the order. Okay, based on this definition right up here. Okay, now let's try to prove it in general. Let's try to prove this result in general. So we're trying to show that B will also, let me come back up. We're trying to show that B will also have the same order as A. And so now what I did is I just multiplied the two congruences, namely the one in the definition right here, and then this guy up here. Notice there's an understood 1 here, right? So you see when you multiply this against this, you get this statement right here, okay? Now, let's move along. Now, it makes sense to raise both sides to the kth power, so let's do that. A to the k plus 1 quantity raised to the k power. And it's understood to be mod n here. Okay, now, so raise that to the k. Now, the nice thing about congruences is you can often treat them exactly like equalities. And so this congruent symbol really is behaving exactly like an equality right now. Okay. Now, what do we know? We know that a to the k, you can rewrite this using properties of exponents. You can write this as a to the k. Raised to the k plus 1. K is congruent to b to the k. Okay, but the nice thing about this is a to the k, k is assumed to be the order of a here. In other words, let me write this out to the side. K is the order of a. All right, and so this literally becomes 1 to the k plus 1. Is congruent to b to the k. But of course that makes b to the k congruent to 1. Okay, folks, now that completes the proof. We'll put QED right here. So what did we prove? We proved that if A has order k, so does B if A is congruent to B. All right, that's the result that we just established. Now, let me, I'll get that circle because that's the operative piece right there. Now, let's go back up and just take a look at this example right here. And I'll just let you guys do this. Notice that for this result to be true, if this result is true, this would also, you can verify, I'll let you guys do that. You can verify that what's a number that's congruent to 4? Okay, that would, mod 7, that would be 11, right? So verify that 11 cubed is congruent to 1. Okay. Now, that's not too hard, actually, if you just consider 11 squared. 11 squared it's not too hard to verify that that's congruent to 2. And again, I'll just write down the intermediate steps here. That's congruent to 2. But if you multiply by 11, you get 11 cubed is congruent to 22, which is congruent to 1 mod 7, right? So again, a concrete example of this working. 4 has an order of 3, but so does 11. So does 11, and 4 and 11 are congruent mod 7. Hope you enjoyed.